switch up the chiral centers, right?
Yeah, all of them, not just one. If it was only one, it'd be diastereomers, right?
Yeah.
Okay.
Yeah, so you need to switch. If for an enantiomer, everything switches because it's a mirror image.
Everything, not just the chiral centers?
No, every chiral center.
Oh, okay.
Yeah.
Okay.
Yeah. So we're gonna I want you to do those. We'll start out with that Wednesday, and then
before we
we'll
start,
talk about the
does anybody have any
pre-existing
questions about
stereo center
anything?
stuff. There's another handout
I do.
that I'll open
Well,
up,
who was that?
and
This
then
is
that way
Brianna.
you can
Good
have
morning.
it to follow
Come on,
along
child.
and fill it in. And then
So I
on
was studying with a friend.
Friday,
Me and Ariana had a question.
what are we doing
When we were
Friday?
doing the
On
quiz,
Friday,
can
I
it
think we'll
be
just do a little review,
superimposable,
and then I'm
like
gonna
an
introduce
image,
another
and
topic.
it not be a mirror
And by the
image?
time we get to the exam, we'll
And if
have a
we-
nice
Superimposable.
block of
If it's not a
information
mirror
that we can
image.
take a test.
And yeah,
Yeah,
But I think those quick
Okay.
tests
yeah,
that
that's
come up
possible.
quick,
That's
I think
that.
that's
But
much.
if it's a mirror
It's
image,
better,
then
it's
it's
more
not going to be
beneficial
for you.
superimposable. Remember, because you're not gonna be able to line everything up.
okay.
That's
It
the
was just a
But-
question because
for the
it was
assignment,
like I
when
think
it,
it was like one of the
so
questions.
like, do we
the
like
quiz, like the
print it off and write on
response
it and
that it
scan
gave
them?
after you got it right
Yeah,
or
you could do
wrong,
that.
it
If you got a
wasn't
printer, some people
correct
don't
to
have a
what the
printer.
actual answer
So if you
was.
want to
Let me pull it up.
pull it up in your device and annotate it,
I'll take about 2
and then
minutes because I think
upload it that way,
one
you
of
can
those
do that
answers
too.
may
Okay.
Yeah,
have
however you
been
want to
messed
do it.
up.
Because
And I can
I
Yeah, it
don't
was.
really require them
I
to
was
be
able to see,
printed
get the
and
answer
scanned
right, but it
because
was
some
like the
people don't have printers.
response, like this my second attempt, I was able
So
to get it
if you
right
can
because
find a
like
way to
the
write
first
on
attempt
it, if
was
you
like
got a
kind of
touch screen
confusing.
laptop or you
So I
got
was
an
like what it was
iPad or
asking.
something like that,
I'm gonna pull
do
it
that.
up. I normally don't do this, but
Okay.
So
I'm
we
gonna do it.
freehand, like we
Yeah,
wrote,
I'll wait like 2 more
wrote it
minutes
out
before
and
we actually
everything
start.
ourselves. Would you take that?
If you did it by hand, sure.
Okay, good. Yeah,
I ain't
thank you.
tripping about that. If you turning your work in, I ain't gonna tell you, oh no, you can't handwrite it. That would be stupid.
Okay.
Some teachers
Yeah.
may be stupid. I'm not one of them. Yeah, but I know we do have some people like that. That's a power trip. That's ego.
Which one was
When
it?
it
This one?
only got to be one way. That's egotism. I don't do that. So if you handwrite it and turn it in, by all means, if
Do you
you turn it
remember
in,
which
we good.
I believe she's asking the same question I emailed you about.
Any other
So it was this
questions?
one. Yeah, I
8
had
minutes
forwarded
over.
your email.
I have one
It's
more
this one,
question.
isn't it?
Go ahead.
Question.
So
I think it was about the.
I think it's
wait,
called
not that one.
antimeters.
It was
Or
about
relationship
I
between
I think it was
changed
question
everything.
5.
configuration.
And
It was
that,
question 5, I think.
Yeah, enantiomers. Okay, I just wanted to
Yeah, that's
clarify
number
that.
5. Yeah.
yeah.
So what's the
Okay, thank
relationship
you.
between A
All right.
and B if A stereo centers
Just wanted to
have
clarify
configuration
one thing.
RS?
So the question
Go ahead.
is for number 5
When a
is
compound
to figure
has
out
two
what the
chiral
configuration
centers,
is on B, right? So
I
let
was
me do
reading
this.
that
Let me
you would think there'd be 4
let's see
enantiomers,
if I
but
can.
there's only actually
I'm gonna take a
3
screenshot of this
because
because I
of
need to write
a
in.
compound.
Because there's a these
Well,
are Fischer
so for
projection.
meso,
So
it's
there's a way
different,
to
right?
actually look
A
at them
meso compound would
to
be
figure out what's
something
going
like
on, right?
let
So
me
we
see
said
if I
it,
can.
it gave you
I'm
that
not
this was,
sharing right now. Meso
or,
compound would be a compound
and I'm
that's
writing
not
with my
chiral,
mouse, so excuse my
but it has chiral
crappy
centers in it.
handwriting.
And it just happens
Let me
that
make sure I'm
one side is a
recording
mirror
too.
image of the other side. I can show you that.
Okay.
I think I am.
Hold up. Let me do that right quick. That's a good question. Watch it. Watch
Yeah,
it. Watch it
it
take
is
forever.
recording.
Just
Okay.
watch. So
I was just wondering because in the handout it was asking for the number of stereoisomers, and I noticed that like some of them had like 3, and I was thinking they would have 4. So
if it's got 3 stereo centers, then it's gonna have 8 stereo.
All right. So it says this.
no, I mean
that
like
these two
it
are
had
RS.
2
It gave
centers,
us
but it
that,
only
right?
had 3
Hey,
stereoisomers.
let's figure
So I
that
was
out though.
thinking
That's
if
not
that
possible. So would it be in a Fischer projection? The
Let me
formula
show
is
you
2
how
to
to.
the n.
I think I talked about this in
Yeah,
the
but
video.
then one was a
So
meso.
anytime you have
meso,
a
I
Fischer
guess.
projection,
So
that's
there's like
basically
so
like
if
it's
one
gonna
of them
look like
was
this.
meso, it's still a
It's
stereoisomer.
crappy
It's
because
just
I'm
not
writing with my
chiral.
mouse, but this
Okay.
is
Because if
hold
it's
up.
meso,
So you can't
that means
see
that
my screen.
come on, if that means that the chiral centers, one side is a mirror image of the other side, and so it just kind of. Let me give you an example. So if you have
What about
something
now?
like this,
Yes.
Okay.
so where the 2 chiral centers are
So
adjacent,
we got this right. So
A Fischer
Mhm.
projection is like basically looking from
Mhm.
underneath
That's
the
actually a
carbon,
mirror plane right
kind of
here.
like looking under a car.
And this side
And so
and this
if
side
you, if
look
carbon is,
like
if it's
they're mirror
tetrahedral,
images. And so if that's the
like
case,
this,
then the compound
I'm just
itself will
gonna-
be what we call
this is
achiral
crappy because I can't write.
because it's meso.
So if it's like that,
So
right?
that means that one
What a
side
Fischer
is a mirror
projection is
image of the
basically
other
looking
side.
from this view
And that
underneath.
takes away the chirality.
Right. So what
because
you're gonna
now it's
see is
symmetrical.
4 groups, kind of like
So
that.
even though both of these are chiral centers and they both have a configuration, overall the molecule is not chiral because of that, because of the fact that it's meso.
Right. So in a Fischer projection, we're gonna talk, but it's still
We'll
talk about some more of these in a minute. So
It's
the
just
two
not- it's
top
just not
groups
chiral.
are on a dash.
Okay.
So if it's 3 plus a meso,
So if
then
you got an atom in the
the
middle, let's
meso
say
still
carbon,
counts.
the 2
It's still
top groups are
4
gonna be on the
total,
dash,
but one of them is just
and then the
achiral.
2 outside groups are gonna be
Okay.
on the wedge,
That's a good question.
like that.
Every time I think I can sneak
Please
past
assume that.
meso, I can't.
All
Somebody
right, you
always
following
asks
that? So thank you for asking me. And that's for any carbon, any Fischer projection. So the rule is,
for
since this
the
is the
5.39
standard confirmation where the 2
can you
top,
go back over how
the
you
top and bottom are going
prioritize
back
that
into the
one again?
screen,
Because I kind of got
and then
confused.
the 2 horizontals are coming out,
8.
right?
That's
The
another
way you
page.
determine configuration is for
How-
Fischer
how do we
projection, you gotta
prioritize this one?
prioritize it, and then you find out
Yes.
where the H.
Okay, so
So
the
priority
ethyl
wise,
is CH2.
this is my chiral center.
CH3. It was
And
kind
the
of
groups
messy
around
too, so
it,
that
I
didn't help.
have
And then the methyl
iodine,
is
I have
CH3.
hydrogen, I have a
Right?
carbon right
Okay.
here, and I
So
have another
basically,
carbon right here.
the first atom is carbon.
Right. So when I'm
Carbon,
prioritizing this,
carbon,
we're gonna talk more
oxygen.
about configuration today, right?
Right.
That's what you, because
But
this
when
is
I'm
your chiral center right
prioritizing
here.
this, iodine
Right.
is gonna be
So with oxygen is going to be 1, right? Because it's got a higher atomic number than carbon.
Yes.
So now you're just comparing the carbons, right? So with this carbon right here, it's connected.
All right,
the
so
next
when I'm
atom is connected
prioritizing
to
this,
is
iodine is gonna be
hydrogen.
number 1. It's gonna be highest
Right.
on this.
When you look
stereo
at this
center.
carbon,
Iodine is
here,
1, and then
and this
between
one
the 2
here,
carbons,
those
here
2 are both connected to other
and
carbons.
here, this
And
carbon is
so
gonna
they're
be
both
2,
going to be higher
and
priority
then
than
this
the
carbon
methyl.
will be 3,
Okay. So
and then hydrogen
now when
is
you
gonna
go
be
to the
4.
carbon,
Hydrogen is always the
Yeah.
lowest priority
I got
group
confused. So
on an atom, unless
that
there's a
would
lone
mean
pair.
that
And the lone pair is the only thing lower
that
than
hold on, wait a
a
second.
hydrogen.
So we're going to go to the next atom, which is right here, right?
right,
All right.
And then for this one, we're going to
So
the next
far, so
atom, which
good,
is right
yes?
here.
Yes.
right.
All right. And when
So
we
when we
compare those
when we
two atoms, that's where your point of difference comes
prioritize,
in,
then we can determine the configuration.
right? Because
Right,
this one is bonded
clockwise.
to
If
hydrogen,
the
and this
groups are
one right
oriented
here is bonded
clockwise,
to oxygen twice.
right, it's R.
Yeah. So the
If they're
priority was
counterclockwise,
1. We
that
said
was
that
off
this
the
one is
screen,
going to be
my bad.
4. That's the lowest
Right.
compared to the other 2 carbons.
Right, if
And
it's
then the top
counterclockwise,
carbon was 3, and then this carbon was
then it's S. R is rectus or right hand. That's clockwise. S is sinister, left
I didn't
hand,
know that
counterclockwise.
for CH2.
So
for
when we
ethyl,
prioritize
had to
these
go
groups
to the
right here,
the next atom.
so 1 is
which
here,
in that case
is
was
that
a
right?
CH3.
Yes.
2
was
is
a
here,
carbon.
and 3 is here.
Okay.
And the next atom here was also
Following?
a carbon, but that
Mhm.
carbon was bonded to something
So
other
when
than
we
hydrogen.
count to 3,
Right, I understand
are
now.
we counting
Yeah.
clockwise or counterclockwise?
Okay.
So 1, 2, 3. That's
All
going
right,
this
thank
way in
you.
All right.
Yes. Counter.
counterclockwise. Okay, so
Any other
now,
questions?
even though it's counterclockwise, H is on a horizontal position. When that's the case, you got to reverse it. All right, so if it's
I'ma stop
counterclockwise,
sharing
it
and
will
stop
be S. But the fact that
recording,
H is
and I'll make
on
sure
a
all of this is
horizontal,
on the
we have to
recording
say
too.
that it's R. That's how
Somebody
we do
is
Fischer
listening
projection.
with the same question, but
If
they're
H
not
is
asking
vertical,
questions.
you leave it. That's fine, right? I always like to teach that
All right.
by saying if H is pointed up towards heaven, keep it. If it's
Is it-
going horizontal towards hell, reverse it.
Is it always going to be H or just it just it
Whatever the
happens to be
lowest,
H?
if the lowest priority group,
Okay.
right? If the lowest priority group is horizontal, you reverse the configuration. So even though it looks like it should be S, the fact that this is horizontal means that it must be R. That's for any Fischer projection. We're gonna do more today, so don't worry, don't panic. All right, same thing with the bottom. Is everybody clear on the top?
Yes.
All right, let's do the bottom stereo center. Cause see now, when you have more than one stereo center, That means you have to do that both stereo centers are gonna have a configuration, a specific configuration. Didn't mean to erase that. All right, so that's R. On the bottom, this carbon right here is my stereo center. And then I'm gonna prioritize. Nitrogen is 1. Is that right? Because it's higher, it has a higher atomic number
Yes.
than the other groups. So hydrogen, carbon, and carbon, right? So nitrogen is 1. And I'm only looking at the first atom. I'm not looking at the hydrogens attached. I'm only looking at the nitrogen. That's all I care about. All right, so nitrogen, and then which of these 2 carbons do you think is gonna be 2? And how would you tell the difference? We talked
The
about
one on the top
the top
would be
one.
2.
Yeah, because this carbon is connected to an iodine. This one is connected to a hydrogen.
I see.
So that's the point of difference. Yes?
Yeah.
No? All right, so that's 1, 2, and then you know this one is gonna be 3. And then the H is gonna be 4. So now we can count to 3 because we don't care about H. So that's 1, 2, 3. Is that counterclockwise too? Or is that
Yeah.
clockwise?
It's counter.
Counterclockwise, right? So it will be S,
And then you flip it.
Then you
but
flip
then
it.
H is horizontal, so this has to be R. So I think that's the problem in the question because it's R. I think I gave it as RS.
Yes.
So that's the problem in the question. So we'll fix that. And if you got it, I'll actually just put a 3 points extra credit because I think it's worth 3 points. So
Mm.
this is RR. Are you following?
Yes, sir.
So now let's do the other side. All right. So this carbon right here is my stereo center. And then of course, this is 1. That's 2. You don't even have to try to reprioritize it because you already did it over here. And that's 3. So what is that?
That's
It's
counter.
counterclockwise, isn't it?
Wait,
So
yeah.
why is the second C3 instead of 2? Because it's attached to the nitrogen.
Which one? This one?
Yes.
You said why is it not 2 or why is it 3? I'm sorry. You're right. Hold up. Boom, boom. You're right. This is 2. My bad. I got too excited. So now that's what? That's clockwise, isn't it?
Yes.
Yeah. So this is 1, that's 2, and that's 3. You're right. So boom, that's clockwise. So what would it be normally?
It would be R normally, but now it's S.
Now it's S because the H is going to hell, right? It's horizontal. So now this is S. And then on the bottom, let's do the same thing. We're looking at this carbon now, right? So nitrogen is 1. The top carbon up here is 2. And then this carbon is 3. Yes? Is that also clockwise or that's that counterclockwise?
That's
1, 2.
clockwise.
That's counter.
That's counterclockwise. And I'm counting the 3. 1, 2,
Yeah.
3. That's
It's counter.
counterclockwise.
Right.
But H is horizontal. Is that right? So we're going to reverse it. You following? So the fact that if it's counterclockwise, it would normally be S. But since H is horizontal, we're going to change it to an R. So now what's the relationship? This is SR, this is RR. Are they diastereomers or are they enantiomers? And how would you tell the difference? Let's think
They're
about
die.
They're not a mirror image.
not mirror images. Why? Because if B was a mirror image of A, then both of these should be different, right? They both should be the opposite of what's over here,
Right.
right?
Right.
This is RR, the mirror image by default has to be SS. Is that right?
Yep.
Okay.
But it's not.
That's why it's a die because one of them is
So
different.
now these are diastereomers. I'm not going to try to write this whole word out with this mouse.
Okay.
But they are diastereomers. Put some dots out here. Y'all know the rest. Diastereomers. So now, say that again.
I was gonna say, so with that, basically it'll look the same, but only one of them will be a mirror.
Yeah, only one stereo center will be opposite. Yes.
Okay.
So let me fix that, and it should. But I have that here in the diastereomers. Maybe the explanation is wrong. I might have copied and pasted because I have it here as diastereomers.
Yeah, the feedback says that they're mirror engines.
Yeah, I think I just was being lazy. Copy and paste. What did we say that was? That was RR, wasn't it?
Yeah, it's R.
What are you doing? My computer is a piece of crap, by the way. So stuff that normally would take a millisecond takes like a half a second. Let's see what's in the feedback. They're not. Fix that. Yeah, that's my fault there. Now that's better. And I'll change, if you got that wrong, then I'll give you the points back. Matter of fact, I'll just add 3 points back to the quiz because I think that was worth 3. But they did give us a chance to, to talk about Fischer projection. So that's good. Because we were gonna do that anyway today.
Okay, glad we did.
Yeah.
I was confused.
Yeah. All right. Any other questions? I think that was a good introduction. So we've talked about. Let me go back to my iPad so I can write properly, even though that's pretty crappy too.
Are we also gonna go over pre-existing stereocenters?
Not today. I'm gonna send videos for that today, and we'll do that Wednesday. So
Okay.
don't do that quiz yet, because it's not gonna make sense to you. Hold up.
Wait, but okay.
You already took it?
Yes.
Send me an email so I can reset it for you, because I don't want you to have a bad grade that's 3. This is a CH3, by the way. And then you comparing that with these 2 carbons right here. That's what you're prioritizing.
So
I bet you don't have no
The
studies
car-
on. I
the
bet
one
you
to the
$100.
right,
Is 1.
$100. You don't have
right.
no
So
studies.
then
The carbon to the left is 2.
2. Then the CH3 would be 3. Then
So
Yeah.
you're saying this is
the one to the
1,
right,
Yep.
1.
okay, and that's 2, and that's 3.
Yes.
Okay, I think this is gonna be a good class. Who was that, by the way?
It was me and Miss Baldwin. We kind of did it together.
Me and Miss. Who is me?
Who is it?
I'm sorry, Brianna.
Oh, okay, all right. So that's 1, 2, and 3, and H is already back. S or R? It looks like it's going counterclockwise. Is that right?
Yes.
So that's
Yeah.
S. Now let's do this one. That one is not as trivial, right?
Bromine's 1.
This is 1. Chlorine is gonna be 2. Is that right?
Yes.
Mhm.
This is one of those cases where 4 is not gonna be on a wedge or a dash, right?
Mhm.
So we gotta do a little extra work for this one. So that's 1, 2, and if you can do that, then the rings are not difficult, right? Once you prioritize them, just turn them into tetrahedrals, right? We're gonna actually do the ring because I don't want you to think I'm letting you off easy. So, oh, he showed us easy stuff in class, but it was hard stuff on the test. No, we do the hard stuff now, so everything becomes easy. So of these 2 carbons, this one, and this one, which one do you think?
The one with
higher?
the oxygen.
Exactly, right? So that's going to be 3,
3.
and then this is 4. Is that right?
Yes.
Yep.
Okay. So here's the task. What would you do? How would you turn that into a tetrahedral that looks like this? Let's see what you made of, what you got. Let's do it like this. What would you do?
Oh, just rotate.
Rock it like I would rock it
And rotate.
like a boat. Push it up.
So the
this way.
chlorine will be at the top.
Bromine. You see how
Right.
bromine is coming out
Wait.
like this?
Mhm.
Can you see my hand? I know it looks kind of goofy.
Right over on the page.
I would push it
Bromine
that
is
way.
coming out. Yeah.
You see that? If bromine is out, I would just
Oh,
push.
okay.
So
Okay.
now it's at the top.
And the chlorine is in the back.
Yeah, boy, I tell you, who was that?
This is Quenisha.
All right, good job. I'm trying to make the stakes high. So I'm gonna ask a hard question before we get off, so if we can do it. I owe you $100.
So wait, question.
Go ahead.
So bromine is on the wedge.
Mhm.
When it ever come to the point where I have to draw my own tetrahedral, I should leave whatever's on the wedge as the main line of the axis.
You know what? You can do that. But if it's like this, right? If it's a chain, because look at the ring up top. You wouldn't have to do that in this case, would you? Because you already have something going vertical.
Mm-hmm.
You understand what I'm saying?
Yeah.
On this side, you already have a vertical axis, right?
Right.
And then at the top, now the top one, you could apply that. You see that?
Yeah.
Because it has the same shape as the carbons in the chain do. Is that right?
Yes.
So then you would do it for that, right? That's a great question. That was a really smart question, by the way. I think this is going to be a good class. It's already shaping up. I can usually tell by the first few lectures whether it's going to be a struggle bus class or it's going to be a good class. This is going to be a good class. So here's my tetrahedral. Is that right?
Mm-hmm.
And I have 3 over here. And I always just turn these into balls, right? Make it easy. And then this was 1 and that was 2. What do you got to do to 4?
Oh, we have to put
Gotta
on
rotate it, put it on that carousel. Is that right?
Mm-hmm.
At the fair, get your funnel cake. Turn it. What's going to happen to 4? Where's 4 going to go?
To the back.
To the back where chlorine is. Is that right?
Yes.
Yep.
And then chlorine is going to come with 3 is, and 3 is going
Yeah.
to swap with 4. Is that right?
Yes.
So let's
Yep.
draw that. Let me see if I can squeeze it in here. So 4 ends up here. 1 is here. And then 2 is here. And 3 is here. Is that right?
Mhm.
So now we just need to count the 3.
It's still S.
Counterclockwise.
It's S. Great. Man, y'all smart. I like that. So this is S also. Do you see how you can go from taking a shortcut to all of a sudden now I got to do something different? It depends on what you're dealing with. Like everything is going to be dependent on that.
So Dr. Russell, just to clarify, even though we found a configuration without the lowest priority being on the dash, we still have to change it.
Yeah, you keep that. You keep that because see, the lowest priority group is not wedged or dashed at all. You can't apply the shortcut.
Oh, so you only apply the shortcut if the
lowest priority group is on a wedge or on the dash.
Okay.
Good question. Y'all are doing great, by the way. I like that. All right, somebody do the Fischer projection H. Whoever finishes this first, that's lunch.
Say less.
We got 4 minutes. Is that right? Are we 9:30 to 10:30?
So we doing both of the carbons?
Gotta do both of them. Can't get lunch half step. You gotta do them both.
Okay.
Again, what are you looking for if it's a Fischer projection? Everything has a pattern to it, right? If it's a Fischer projection, your mind should be, is H horizontal or is it vertical? That's the first thing you should be thinking about. And if it's horizontal, I know that everything I see, I reverse it. Is that right? Because in a Fischer projection, these groups are actually wedged, right? And the vertical groups are dashed. And when you see ME, that's just an abbreviation for methyl. It's a CH3 group. One time a student asked me if it was methylenium.
Methylenium.
Yeah, they thought it was an element on the periodic. They was looking for it on the periodic table so they could prioritize it.
You just want the configurations for both of them or just the top one?
No, both of them.
Okay.
The first one with it, actually, instead of blurting it out, just type it in the chat. First one with it. I'm looking at the chat now. Okay. Quenisha got it. She said it was RR. And I got another one that said SS. So now we got 2 finalists.
Oh, not 2.
Quenisha and Natalie. So if whoever is right is gonna get lunch. All right. So let's do it. What's on this chiral center right here? What's the priority? OH is 1. Is that right?
Yes.
This carbon down here is going to be 2.
2.
Right.
This methyl is going to be 3.
3.
H is horizontal. Going to hell. Going to hell, you got to go backwards. Right?
Okay, it's SS.
You gotta
So
flip it, yeah.
So this is
That's R.
it's clockwise, isn't it?
Yes.
But H is going to hell, so you got to change it. So it's R. Is that right?
Yes.
Yeah.
And let's look at the bottom one. The bottom one says that that's 1, that's 2, and that's 3. Is that right?
Yeah.
Yes.
And that's clockwise also, isn't it? Is that right?
Yeah.
Yeah, that's right.
But H is horizontal, so you have to flip it.
So that should be R, but it should be what?
S.
S. So nobody was right.
Damn. Oh, excuse me. Yeah.
That's all right. I was saying the same thing in my head because I thought we were going somewhere with it. I'm just joking. I'm just joking. Hold up. Let me look at the top one again.
Wait, hold on.
Yeah, it's SS.
I think it's SS. It's SS.
The first one is S.
Yeah, you're right.
Natalie got
Somebody
lunch
was
last
right. Hey, Natalie.
Thank you.
Where am I? All right, I owe you another lunch. But that's good though.
Wait,
So let me ask, go ahead.
I'm confused. Why is it S now?
Okay, so the groups are oriented in a clockwise fashion, is that right?
Right.
But the H is horizontal. So I have to reverse it because this is a Fischer projection.
Right.
So if the groups are oriented clockwise, that would normally be R.
Oh, I'm tripping. Okay,
But
yes.
since H is horizontal, I reverse it to S.
Right, yeah. I just
Yes.
I apologize for that.
Is it Kanisha? Is that right?
Yes.
Sorry,
Yes.
Well, it's Kinesia.
Kanisha. I'm just all right. So just email me, and we can set
Okay.
something up. All right. Here's another question. What would the enantiomer of that look like? How would you draw it? That Fischer projection.
It would
It would be the mirror image.
Well,
yeah.
Yeah, it would be
It will be OH on the left.
like that.
Yeah.
And
And then-
yeah, pretty much.
Yeah.
Okay. I just want to make sure that so all them definitions don't matter if you don't know how to apply it. So I'm always going to be asking questions that refer you back to some information that we already covered. Because you can't forget stuff. Everything matters.
So if it was a diaster, how you
Yep.
said?
Yep. If I
Guys,
do the diastereomer, good question. What would you asking? What would that look like?
Right.
Yeah, let's do it. We gotta. So this would be OH, and that would be OH. That would be one diastereomer.
Oh yeah.
You follow me? And the other diastereomer would be with the OHs on the other side.
Both at the top.
You following that?
Yes.
Yeah. And with diastereomers, you're only changing one stereo center from the original image. So that's the original image. So I left this OH the same and I changed it. You see that?
Yes.
And then in the mirror image of the diastereomer, it would be the exact opposite, right?
Right.
I would be leaving this OH the same and changing this one.
Right.
But you only change one stereo center at a time.
Okay.
Yeah. I think we got to stop. It's 10:32, and I'm going to take some time today to chop up these videos so that I can put them on YouTube so you can refer back to them. Because this was a good lecture, a good class. A lot of good questions. All right.
Are you posting videos for Wednesday?
Yeah, I'm gonna post what did we do Wednesday?
Wednesday was just.
I mean, like,
orientation.
No, Wednesday we just went over the syllabus. Is that right?
Yeah. Friday we started learning.
Friday we started. So from Friday and today, I'll be posting those today. I'm gonna start chopping them up as soon as we get off. For Wednesday, I'm gonna send a new video, and this is what I want you to do now. I'm gonna kind of put you on your own.
What, a new YouTube?
Mm-hmm.
Okay.
I'm gonna send it as soon as we get off of here, so I don't forget. But I want you to do this problem, and when we come back Wednesday, we're gonna open up with that, and then we'll start that next topic.
You still got me for the reopening my quiz?
Oh yeah, I wrote you down.
Okay.
I got you.
I did it
Don't
too,
worry.
Dr.
Say again.
I did it too, but I think he gave
I
us
thought it
2
was because
attempts.
the quizzes were up, so I thought we were just supposed to do all of them before Monday.
No, I just did that for my own sake because I know me. I got a million things going, so I would have forgot.
Okay.
Yeah, but I'm about to reset it. If anybody took it and wants to be reset, just put that in the chat real quick. That way I'll know who to reset.
I have a question.
Go ahead.
So for the quizzes, are they due like the week up, or are they due before the exam? Everything's due before the exam.
The quizzes are due after you watch the videos.
Okay.
I wouldn't wait because what's gonna happen is the other 35 classes you taking, you're gonna have stuff due, and you're gonna have that quiz just hanging out there, and then when it closes, then we get an email. Dr. Russell, I don't know what happened, but can you open it back up? So just take it after you watch the video.
Okay, because I already watched the videos, and I just haven't had a chance to get to the quizzes.
Yeah.
So
Long as
are they still open?
It's open. It will stay open until we take the test. Then all that stuff will close, and then we'll be in another section.
Okay, yes, sir. Thank you.
Yeah. All right. So before we go, I want y'all to look at 537. Look at the question, what it's asking. How many stereoisomers would you expect? How do you know that?
With the two.
Two to the end. If you know it, so you got to be able to do two skills. You got to be able to identify chiral centers. And then the second skill is you got to know how to take that little exponential formula and plug in and get the number of stereoisomers. Is that right?
Yes.
Yeah, so that's two skills. And then I also want you to practice on, this is not highlighted, but this will be, you'll have questions like this on the test, 538.
Okay.
Draw the enantiomers. My suggestion, draw a line here and just draw the mirror image like that.
Okay.
If it's easier for you to just reverse everything, then do that. But
also, with that, for enantiomers, you only switch up the chiral centers, right?
Yeah, all of them, not just one. If it was only one, it'd be diastereomers, right?
Yeah.
Okay.
Yeah, so you need to switch. If for an enantiomer, everything switches because it's a mirror image.
Everything, not just the chiral centers?
No, every chiral center.
Oh, okay.
Yeah.
Okay.
Yeah. So we're gonna I want you to do those. We'll start out with that Wednesday, and then we'll talk about the pre-existing stereo center stuff. There's another handout that I'll open up, and then that way you can have it to follow along and fill it in. And then on Friday, what are we doing Friday? On Friday, I think we'll just do a little review, and then I'm gonna introduce another topic. And by the time we get to the exam, we'll have a nice block of information that we can take a test on. Because I think those quick tests that come up quick, I think that's better, it's more beneficial for you.
Dr. Russell.
Yep.
For the assignments, do we like print it off and write on it and scan them?
Yeah, you could do that if you got a printer. Some people don't have a printer. So if you want to pull it up in your device and annotate it and then upload it that way, you can do that too.
Okay.
Yeah, however you want to do it. Because I don't really require them to be printed and scanned because some people don't have printers.
Okay.
So if you can find a way to write on it, if you got a touch screen laptop or if you got an iPad or something like that, do that.
Okay.
So would you freehand, wrote it out everything ourselves? Would you take that?
If you did it by hand, sure.
Okay, good.
I ain't tripping about that. If you turn your work in, I ain't gonna tell you, oh no, you can't handwrite it. That would be stupid. Okay. Some teachers may be stupid. I'm not one of them. Yeah, but I know we do have some people like that. That's power trip. That's ego. When it's only got to be one way, that's egotism. I don't do that. So if you handwrite it and turn it in, by all means, if you turned it in, we good.
Okay.
All right. Any other questions? 8 minutes over.
I have one more question.
Go ahead.
So and I think it's called Enantiomers. They change everything.
Mm-hmm.
Everything's gonna be
Enantiomers.
Yeah, Enantiomers. Okay, I just wanted to clarify that.
Yeah.
Okay, thank you.
All right.
Just wanted to clarify one thing.
Go ahead.
When a compound has two chiral centers, I was reading that you would think there'd be 4 enantiomers, but there's only actually 3 because of a meso compound. Well,
so for meso, it's different, right? A meso compound would be something like, let me see if I can y'all still, I'm not sharing right now. Meso compound would be a compound that's not chiral, but it has chiral centers in it. And it just happens that one side is a mirror image of the other side. I can show you that.
Okay.
Hold up. Let me do that right quick. That's a good question. Watch it take forever. Just watch.
I was just wondering because in the handout it was asking for the number of stereoisomers, and I noticed that like some of them had like 3 when I was thinking they would have 4.
So if it's got 3 stereo centers, then it's gonna have 8 stereoisomers.
No, I mean like it had 2 centers, but it only had 3 stereoisomers. So I was thinking
that's not possible, because the formula is 2 to the n.
Yeah, but then one was a meso, I guess. So they were
it
saying
was so if one of them was meso, it's still a stereoisomer. It's just not chiral.
Okay.
Because if it's meso, that means that come on, that means that the chiral centers, one side is a mirror image of the other side, and so it just kind of. Let me give you an example. So if you have something like this, where the 2 chiral centers are adjacent, right? There's actually a mirror plane right here, and this side look like they're mirror images. And so if that's the case, then the compound itself will be what we call achiral, because it's meso. So that means that one side is a mirror image of the other side. And that takes away the chirality because now it's symmetrical. So even though both of these are chiral centers and they both have a configuration, overall the molecule is not chiral because of that, because of the fact that it's meso.
Okay.
But it's still considered a stereoisomer. It's just not chiral.
Okay.
Yeah. So if it's 3 plus a meso, then the meso still counts. It's still 4 total, but one of them is just achiral.
Okay.
Yeah, that's a good question. Every time I think I can sneak past meso, I can't. Somebody always asks about it. So thank you for asking me.
Could you for the 5.39 letter A, can you go back over how you prioritize that one again? Because I kind of got confused.
5.39A. That's on the other page. Yeah, here. How do we prioritize this one?
Yes.
Okay, so the ethyl is CH2, CH3. It was kind of messy too, so that didn't help. And then the methyl is CH3, right?
Okay.
So basically, the first atom is carbon, 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 oxygen. Right? That's because this is your chiral center right here.
Right.
So with oxygen is going to be 1, right? Because it's got a higher atomic number than carbon.
Yes.
So now you're just comparing the carbons, right? So with this carbon right here, it's connected. The next atom is connected to is hydrogen.
Right.
When you look at this carbon here and this one here, those 2 are both connected to other carbons, and so they're both going to be higher priority than the methyl.
Okay, so now when you go to the carbon,
yeah,
that's why I got confused. So that would mean that that hold on, wait a second.
So we're gonna go to the next atom, which is right here, right?
Right.
And then for this one, we're going to the next atom, which is right here.
Right.
And when we compare those 2 atoms, that's where your point of difference comes in.
Okay.
Right, because this one is bonded to hydrogen, and then this one right here is bonded to oxygen twice.
Right.
Yeah. So the priority was 1. We said that this one is going to be 4. That's the lowest,
right,
compared to the other 2 carbons. And then the top carbon was 3, and then this carbon was 2.
Okay. I got confused, but I didn't know that for CH2 for ethyl you had to go to the C.
The next atom, which in that case was a CH3, well, was a carbon.
Okay.
And the next atom here was also a carbon, but that carbon was bonded to something other than hydrogen.
Right, I understand now.
Yeah.
Okay. All right, thank you.
All right. Any other questions? All right, I'm gonna stop sharing and stop recording, and I'll make sure all of this is on the recording too, because somebody is listening with the same questions, but they're not asking questions. So that's fine. All right.